Hey everybody, in this lecture video, we will take a look at topic number 28. And next couple video that follows, we will begin to talk a little bit about geometry. So in this video, we will do the very basic, okay? Talking about lines and angles, all right? So I'm gonna draw some picture here. So as you know, a line is made out of infinite number of points, okay? That's why we say line never ends. So lines made out of infinite number of points. So, oh, sorry about that. So if I draw a line, okay, and pick 2 points on there, just 2 points, called it point A and point B, then we can denote this line as line AB, okay, with the two arrows. That's how we actually denote for lines with the two arrows. So remember, lines never end. That's why number lines never ends. There are infinite number of numbers on a number line, okay, because lines never ends. A segment is simply part of a line with two endpoints. Okay, I'm going to call it A and B for right now. So basically, if I would chop off the left side and the right side of my point A and point B, then what's left of it will be called a segment. Okay, sometimes people call them line segment, which is correct. All right, a segment is actually part of a line with two endpoints. Okay, so we can denote this as segment AB with no arrows. Okay, arrow means this is a line. Okay, so why do we talk about segment? Because line segments makes up our polygons. Polygons are shapes like triangle, square, rectangle, pentagon, hexagon. Those are polygons. Okay, so lines makes up your polygons, your shapes. Okay, array is also part of a line with only one endpoint and the other end goes on forever. So again, if I have my point A and point B again, okay, and this time I'm only gonna chop off one end of the line and let the other side goes on forever, then we can call this array AB. Okay, it turns out two rays makes up an angles. Okay, two rays makes an angle. So basically, when we talk about an angle, okay, so let's say here is a point A, okay, here is a point B. So let me draw a ray, okay, and then what happened is, what happened if another ray shares the same endpoint as the point A? We're gonna call this ray A to C, okay? So two rays forms an angle. So now we can call this angle A, or we can call this angle B to A from A to C. So rather than write A twice, we can write A one time. So angle B to A. So that's ray B to A and then A to C. Okay, so we can call this angle BAC, or we can say from ray C to A, from A to B. We can read it backwards. Okay, so these are three different ways to describing an angle. All right. Parallel lines are two lines with the same plane that never intersect. So most of us remember parallel lines never intersects. Okay. Otherwise, we call them intersecting lines. Okay. So let me just kind of write it like this. Okay. So I'm gonna say line one is parallel. So there's a notation for parallel. Line two. So that means if I have two lines called the line one and line two, and I say they are parallel, that means they are parallel and they will never intersect on the same plane. Think of the word plane like a surface, okay? Um, like a piece of paper, right? Piece of paper, that piece of paper is a plane. Perpendicular lines are two lines intersecting at exactly 90-degree angle. Okay, so if I say line one is perpendicular, that's our symbol, to line two, then these two lines will intersecting at exactly 90-degree angle. And normally we will say, we will make a little mark, the 90-degree angle mark this way. Okay. All right. Two lines intersect. two lines intersect if they have exactly 1 point in common. Okay, if they have a 1 point in common, they will intersecting at that 1 point. So believe it or not, these three things, okay, these three things, parallel perpendicular lines and two line intersecting, if they have exactly one endpoint, we will actually talk about something like this again in Math 108 in terms of two different equations, okay, whether they will intersect, okay, whether they will actually whether they will intersect at 1 point or they will parallel. So we will talk about something like this in Math 108 in terms of system of a linear equation in two variables. Okay, so here I just want you to know two lines intersecting, if well, they will always intersect at one common point. Parallel lines never intersect. Perpendicular lines will always intersect at 90-degree angles. So if two lines do intersect, then two pairs of vertical angles are formed. Vertical angles are opposite to each other, so that means their faces, they're facing up, they're facing each other. They're on the opposite side to one another. They are not right next to each other. Right next to each other will be called adjacent angles. So vertical angles are congruent, so that means they have the same angle measurement. So this angle one, right? This angle one, okay, faces angle four. They're opposite to each other. Okay. I don't like that word opposite. I like to use the word they are facing each other. Okay. And in that case, angle one and four are vertical angles and they are congruent. Angle two faces angle three, right? Angle two, that faces each other. So they are vertical angles. Vertical angles are congruent. All right. So if angle two here is 70 degree, sorry, I'm left out the degree notation, then what should angle four be? So whenever you see two lines intersecting at one common point, then the angle faces each other is always called the vertical angles. So vertical angles are always congruent. So angle four will be 70 degree. Okay. All right, let's find angle number three. So this one is a little bit tricky. Angle three is way up here, right? So I want you to see that, hey, see if you can notice that this is a triangle and triangle has 180 degree. So in order to find this angle, I would need to know what angle two is because angle three is also inside of another triangle. So in order to find the missing angle, then I need to know the other two in order to find my missing one. So if I know what angle two is, I can find angle three. So how do I know what angle two is? Well, angle one and angle two, see the two lines intersect at one point, and angle one and angle two faces each other. So one and two are vertical angles. So if I know what angle one is, then I know what angle two is. Then I can find angle three. So angle one being inside of a triangle, and triangle is 180 degree, that means I can say angle one is going to be 180 degree, right? Minus the 42 minus the 62. So minus the 42 minus the 62. So angle one is 76 degree. Okay, so since angle one and two are congruent, angle two is also going to be 76 degree. So angle three being in another triangle, we can say take the total 180 degrees, subtract 76, subtract 53. Then we get to find out what angle three is. That will be 51 degree. Okay. All right, transversal. I think there might be one angle I didn't talk about. Something called a straight angle. So let me go ahead and add up right here. Okay, before I go transversal. Another type of angle is called a straight angle. You know, I mean, we have different angle. We got, right angle. We have Let me see if I talk about it down here. Yep, I do talk about it right here. Okay, different types of angles. Okay, we got right angle, straight angle, acute angle, obtuse angles. Straight angles or adjacent angles. Two angle they're sitting adjacent right next to each other. Okay, that's why that word opposite is used for vertical angles. The two angle face each other. So if you have a straight line and if you have a straight line and here comes another segment or line, this angle and this angle sitting right next to each other forms a straight angle. Okay, a straight angle or a straight line is always going to be 180-degree. Okay. All right. Transversal is a line in a plane that intersect two or more lines in the plane at different points. So basically, in my picture here, I got line L and line M. These two are parallel. So this T is called a transversal. If this transversal intersect two or more lines, okay, at the different points, then that make that line called the transversal. Okay, so this is something called the properties of parallel lines. Okay, so if these line L and line M are parallel, and here comes a transversal, then you end up with 8 different angles. Okay, something called the corresponding angles. Corresponding angles are congruent. Corresponding angles, think of corresponding angles as angles sitting at the similar position on the two parallel lines. Okay, so let's say line L is parallel with line M. Okay, so angle 2 is above L to the right of transversal. Okay, T means transversal. So another angle that are in a similar position is angle 6, right? Up above the line M to the right of the transversal. Okay. So that's why 2 and 6 are what? Are corresponding angles, and corresponding angles are always congruent. Okay. So now do you see angle 3 right here? Angle 3 is below and to the right, right? To the right of transversal below L. So another similar position on the other parallel line M will be 7. So 3 and 7 are corresponding. 1 and 5 are corresponding. 4 and 8 are what? Corresponding. And all corresponding angles are congruent. Okay. Alternate interior angles, okay, are also congruent. Alternate interior angles means alternating the transversal. Okay. Interior means in between the parallel lines. So there are angle 3, 4, 5, 6 are between the parallel lines, right? These 4 angles are between the parallel lines. And alternating means alternating sides. You cannot say angle 4 and 3 are alternate interior because angle 4 and 3 actually sitting on the same line L. So they will be considered as adjacent angle or straight angles. And together they are 180. So the alternate interior, okay, the alternate interior here is referring to angle 4 and angle 6, alternating the side, okay, or the diagonal angle here are parallel. I mean, excuse me, are congruent. And angle 3 and angle 5 are alternate interior angles, okay. Interior means between the parallel lines. Alternate means on the what? Alternating the side of the transversal. Okay. So remember angle 2 and angle 4. See the two lines, the L and the T intersecting at one point. So 2 and 4 are vertical angles. Okay. So if 2 is 60-degree, that means 4 is 60-degree. Therefore, 6 is also 60-degree, right? Alternate interior angles is congruent. 2 and 6 are corresponding angles. That's why eventually you can actually figure it out that 2 and 6 are also the same angles, right? Vertical angles are congruent, alternate interior angle are congruent, vertical corresponding angles are congruent. Okay. So I hope that makes sense. Okay. So there are different things come in play. You got vertical angles, you have alternate interior angles, and you got corresponding angles. Okay, that proves that they're all going to be 60°, for example. Okay, then they're not always 60. I'm just saying if I say 2 is 60, then I can figure out all the other angles. Interior angles are referring to angles between the parallel line but on the same side of the transversal. So that's referring to angle 3 and angle 6 are interior angles. Angle 4 and angle 5 are interior angles. And interior angles always has a sum of 180°. Okay, so let me go back up here. So if I pretend angle 2 was 60°, by the vertical angle, angle 4 will be 60. By the alternate interior angle, angle 6 will be 60. And by the corresponding angle, 2 and 6 are both 60, right? Now, straight angles. If angle 2 is 60, then angle 1, well, straight angle means the two angle, straight angle has a sum of 180. So if this straight line is divided into two different angles, one is 60, the other got to be 120, right? Because together, straight line is 180. So by the vertical angle, angle 3 will also be 120. Okay, by the corresponding angle or by the alternate interior angles, 5 is also 120. Okay, therefore, by the vertical angle, 7 is 120. By the vertical angle, 8 is 60, right? All right, if angle 1, so this is a little bit different. I don't have a parallel lines, okay? I just have two line, X and Z is perpendicular, and there comes another line called Y. That's not a transversal. Transversal is really referring to a line that actually what? That actually intersect two or more lines at different points. Here, all three lines intersecting at exactly the same point. So this is not quite the corresponding interior and alternate interior angles. Okay, but we can still use some of the things we learned so far to figure out all these angles. So if angle 1 is 40°, right? By the vertical angle, do you see the Y and the Z? Y and the Z intersecting at one point. So angle 1 faces angle 4. So angle 4 is 40. Okay. Do you see the X and the Z intersecting at one point? So 3 and 6 are vertical angles. So 6 is already being marked as a 90°, right? So 3 will also be 90°. All right. Now, did you see? So if this is 90, this is actually 90. 3 is also 90. You can pretty safe to say, okay, angle 1 and 2 together is also 90. 4 and 5 together is also 90. But I'm not sure. But what I know for sure is, did you see this line X right here? This line X has three angles, right? Because X, Y, Z all intersecting at one point. So in that case, angle 2, 1, and 6 together got to be 180. So if 2, 1, 6 together is 180, then I can take 180 minus the 90, 6 and minus the 40, and that will tell me that angle 2 is 50°. Angle 2 faces angle 5, right? See this angle X and the angle, excuse me, line X and the line Y faces each other. See these two lines intersecting at one point? So 2 and 5 face each other. So 5 will be 50°. All right. All right, different types of angles. Right angles, 90 degrees, right? Right angle means I have two rays that forms a 90° angle. Okay. Straight angle means I have two rays that forms a straight line. Therefore, straight line has a sum of 180 degrees. Okay, so as long as I intersecting at one point, okay, if I have three lines intersecting at one point, then all the angles sitting on the same straight line will be 180 together. Acute angles, okay, two rays that forms an acute angle. Acute angle means an angle that is bigger than 0 degree but less than 90 degrees. All right, obtuse angles is where two rays, okay, forms an angle, and that angle itself is bigger than 90 and less than 180. Complementary angles are simply referring to two angles that have a sum of 90 degrees. So that means if I have a 90 degree already, and that 90 degree is being divided up into two separate angles. So we can say these two angles, okay, together, okay, are 90 degree, or we can say these two angles are complementary angles. All right, if I already have a straight angle, and that straight angle is divided into two angles, two different angles, then we can say these two angles are supplementary angles, and they have a sum of 180 degrees. Okay, so what is complementary angle? So complementary means together is 90, right? Of 20 degree. What's complementary of 20 degree? So that means if one angle is 20 degree, what should the other one be? Well, you know the two together is 90, so you take the total, subtract the one that you know. So complement of 20 degree will be 70 degree. If you know one angle is already 130, then its supplement will be, well, the two angle together is 180, right? Supplementary means the two angle together is 180. So take the total, subtract the one that you know, then the other angle will be 50 degree. Okay. Now I want you to think about this. Okay. Before we do the homework, before I go over the homework, I want to think about this. If two angles are complementary, what do you think is what's complement of x degree, right? What's complement of x degree? So think about this. If I told you one angle is going to be x degree, what do you think the other one will be? And don't say why. We're not there yet. We don't say why. If one angle is x degree, what should the other angle be? Remember how did we find the 70 earlier? We find the 70 by taking what? We find the other angle 70 by taking the total and subtracts the 20 that was here, right? I just erased it, replaced with x. So to find the missing angle, all you have to do is do exactly what I just said. Take the total, subtract off the angle you already know, which is x. And students say, well, hold on, Mr. Chan, what's x? What's x degree? Remember, when we talk about algebra in the previous videos, x just a degree. X is a term, okay? What is a term? A term can be a number, a variable, a product of some number, a quotient of some numbers, okay? A term is just an object, okay? So what so you don't so you gotta think, okay, what is x? Well, x is x. I hope that makes sense. What's x? People always ask what x equal to. Well, x is equal to x. Okay, an object is an object. Okay, what is a phone? The cell phone you have. What is a phone? A phone is a phone, right? An object is just an object. Okay, so that elevate your level of thinking. You got to think of algebra as the way it is. What is an x? X is a term, just an object sitting there. Okay, it does not always have to equal to a numerical value. Okay, it does not always have to equal to a numerical value. It can just be, you know, just be an object. Okay, what here, if I say here's a rectangle and here's a triangle, I got two objects sitting here. What does it mean? It means I got two objects sitting here. What do they equal to? Well, they don't equal to anything. They equal to itself. They equal to a rectangle and a triangle. Okay. So think about that. Okay. Think about that. It does make students think a little bit differently in terms of algebra. X does not always equal to a numerical value. Okay. It only equal to numerical value when we are solving an equation. Otherwise, they just being viewed as an object, as a term. Consider angle AOC, okay, which later representing the vertex, okay? So the vertex is referring to, who's my picture at? The vertex is where the two rays shares the same endpoint. This is the vertex, okay? And the vertex is always what? Located in the middle. So which letter representing the vertex here? If I have an angle AOC, O will be what? The vertex. If two lines intersect, then two pairs of what are formed? If two lines intersect, then two pairs of what are formed? Two pairs of what? Vertical angles. Vertical angles are formed. All right. Something is a line in a plane that intersecting two or more lines in the plane at different points. So that's referring to a transversal, right? A transversal is a line. Interior angles, property of parallel lines, have a sum of 180 degrees. All right, same pictures. Okay, please find angle 3. All right, if angle 1 is 50 degrees, so if angle 1 here is 50 degrees, find me angle number 4. Okay, so do you see this line right here where angle 1 and angle 4 sitting on? Okay, and now this line is split into angle 1 and 4. So you know this straight angle tells you what? These two angle has a sum of 180. Okay, so angle 4 would just be 180 minus what angle 1 is. Okay, all right, so it's just real quick talking about lines and angles. Okay, thank you for watching.